After the Apollo missions, NASA continued to open new doors in the field of space exploration.
As you're probably well aware, we are still working on other programs, Skylab being the prime effort starting in the spring of next year. We're also working on the cooperative mission with the Russians, which will take place in 1975. And of course, we've got quite a few of the flight control team as well as other center elements involved in the work on the shuttle. So it's the start of a new era, I hope.
In July of 1976, after spending a year in spaceflight, the Viking 1 spacecraft landed on the surface of Mars, becoming the first spacecraft to safely land on the surface of another planet. Viking 1 conducted soil experiments, took 360-degree color photographs, and conducted a search for alien life. Another Viking mission landed on the surface of Mars, followed by the Mars Pathfinder mission, where a remote-operated roving vehicle explored the Martian surface collecting data. The United States followed the Russian space program by sending the Skylab space station into orbit in 1973. Skylab hosted 3 crews before it was abandoned in 1974. 9 years after Apollo 17, with the support of President Ronald Reagan, NASA moved ahead with another manned flight into space.
Beginning with the next flight, the Columbia and her sister ships will be fully operational, ready to provide economical and routine access to space for scientific exploration, commercial ventures, and for tasks.
Woman to travel in space. While her historic flight fell 20 years behind Russian female cosmonaut Valentina Tereshkova, Ride still captured the hearts and minds of Americans everywhere and inspired children throughout the United States to once again take an active interest in the wonders of space travel. By 1984, space shuttle astronauts in orbit would be the first to make an in-space repair of a damaged orbiting satellite. In 1985, 4 STS spacecrafts would complete a total of 9 missions to space. There was even talk around NASA of putting everyday citizens into space aboard the shuttlecraft.
8.5 minutes later, we were in orbit. I asked if I could open my eyes yet, and this is what one sees when you do open your eyes. It's a beautiful, beautiful sight. The crew members, Rick, looking somewhat relieved that the launch went so well. Trusty pilot Dave Walker, unidentified mission specialist Anna Fisher, and straight from the college campus, Dale.
This actually was taken by Dr. Allen with Captain Houck pushing him along as he held our movie camera in front of him, going down into the middeck, and you can see the portable foot restraints that we attached to enable us to stay put. our treadmill that we use for exercise, and some of the lockers. That particular one that's open contains in-flight maintenance equipment, which Eagle Electronics used. And over on the starboard bulkhead of the middeck, you can see the sleep accommodations.
Russia continued to concentrate on long-duration space missions. In 1986, they launched the first modules of their Mir space station to be assembled while in orbit around the Earth. Then, that same year, NASA experienced another horrific tragedy when the Space Shuttle Challenger disintegrated in the air just 73 seconds after liftoff, killing all 7 astronauts on board, including schoolteacher Krista McAuliffe.
The Space Shuttle mission, and it is cleared the
Control program. Roger, roll, Challenger. Good, roll program confirmed. Challenger now heading downrange. Engines throttling up. 3 engines now at 104%.
Challenger, go at throttle up.
Challenger, go at throttle up. 1 minute 15 seconds. Velocity 2,900 feet per second. Altitude 9 nautical miles. Downrange distance 7 nautical miles. Flight controllers here looking very carefully at the situation. Obviously a major malfunction. We have no downlink.
The entire world watches, wonders, and mourns.
This is Mission Control Houston. We have no additional word at this time.
After years in the making, on April 24, 1990, NASA launched the $1.5 billion Hubble telescope into orbit. Designed to uncover the universe through a collection of stunning photos of distant planets and solar systems, Hubble got off to a bumpy start due to a damaged lens. In 1993, Space Shuttle astronauts performed a remarkable spacewalk, fixing Hubble's defective lens and opened the door to the beauty, complexity, and enormity of space beyond the Milky Way. In 1998, the first 2 modules of the International Space Station were launched and connected together in orbit. Other modules soon followed, and the first long-term crew arrived at the space station in 2000. Aboard the International Space Station, crews from all parts of the Earth conduct experiments central to understanding and improving life on Earth. In addition, the space station continues to grow as more parts are added with each manned mission. Then, in early 2003, tragedy struck again as STS Columbia, while re-entering the Earth's atmosphere from a 16-day scientific mission in space, disintegrated. It was later discovered that a chunk of foam that struck the port wing upon liftoff damaged critical heat-deflecting shields. Upon re-entry, the heat buildup caused the wing to melt from the inside out. The wing broke away, causing the craft to spin out of control. Moments later, the craft disintegrated. While the technical causes behind the Columbia disaster have been made apparent, many attribute the real cause of the loss of crew and craft to the changing culture at NASA and other related government agencies. A report released to the public in August of 2003 about the cause of the Columbia tragedy served as a wake-up call to many. In the words of one NASA official to the press,
The measure of NASA's success became how much costs were reduced and how efficiently the schedule was met. But the Space Shuttle is not now, nor has it ever been, an operational vehicle. We cannot explore space on a fixed cost basis.
with such a scathing indictment to consider, is man no longer interested in expanding the boundaries of flight? Have we gone far enough, fast enough, high enough? If there is an answer, the fact still remains that with closing the book on political animosities of old, thanks to the wonder of flight, space is once again a tranquil setting for all to explore. experiment, and admire.
Doors opening at the 195-foot level. Island Collins now, our commander, preparing to board. Meanwhile, the Astrovan is leaving the pad. This is Mission Specialist 5, Charlie Camarda. He will sit in seat 7. That's the mid-deck right seat.
OTC, CGNC.
CNC, go.
Can give you steps 545 and 546 complete. We're ready for GMT Delta adjust.
Copy. And DPS and ISL?
ISL. DPS here.
Step 547, GMT, MET adjustment.
So copies. DPS copies.
As soon as Eileen has her communications equipment on.
OVCC. VCC, OTC.
MS5 on board at this time.
Copy, 1123 GMT.
That's confirmation that Charlie Camarda is now on board. Eileen Collins getting ready for her first initial comm check with the firing room. And Jim Kelly, as we saw, is coming up next.
OVCC, OTC.
PLT on board at this time.
Copy, 1131.
OTC DPS.
Yes, go.
GMT and MET adjustment complete. Ready for IMU platform positioning.
3569 and GNC, OTC.
GMC. Copy that.
And we see Andy Thomas there being prepared for boarding as well.
NTD, CDR, comm check.
CDR, this is NTD. I have you loud and clear. Welcome aboard, Eileen.
Thank you, Jeff. And you're loud and clear also.
Suichi Noguchi from Jackson now steps into the picture.
Houston, PLT, comm check.
PLT, Houston, you are loud and clear. Good morning, Vegas.
Morning, Hawk, got you loud and clear as well. Ready to go.
589 complete, TET 50.
You can see the detail in which everyone is paying to all of the equipment on the crew members, the number of people that inspect that equipment. And we want to make sure that absolutely nothing is wrong with it, and once we close the hatch, that everything is just fine. And there we see Wendy Lawrence entering the through the hatch and onto the middeck to take her seat between Charlie and Andy. You can see the straps hanging down, George. Those straps are used as assist handles to get in and out of the seat. You know, the vehicle's in the vertical here. The crew enters and then has to lay on their backs for launch. Crew, I spoke to each one of them this morning, are extremely focused on the work that they have to get done. The flight plan is very full. They have very little time for free time, so they're focused on getting their job done. Now we see Soichi entering his seat. This is a really good view from the glare shield between the commander and pilot looking aft into the vehicle. And we see Soichi in the MS-1 seat and the two closeout crew members there. We've got George and Lee.
OTC, MS4, contract.
S4, this is OTC. I have you loud and clear. Good morning, Wendy.
Good morning, Mark.
See Steve Robinson entering the crew module, and Wendy, we hear Wendy Lawrence doing her communications checks.
VCC, OVCC. VCC, OTC. MS2 on board at this time, and that is all crew members on board at this time. 1208, thank you.
And Houston, the crew is configured for the simul voice check.
Okay, Discovery Houston for the entire crew, com check.
CBR, loud and clear.
TLP. MS1. MS2. MS3.
MS4.
MS5.
And Discovery Houston, we have you all loud and clear. This completes the air-to-ground voice checks. Thanks.
Range weather.
Weather has no constraints for launch.
Thank you very much, Kathy. Ops manager. The mission management team is working no problems. We are go for launch. Thank you, sir. Discovery launch director.
Discovery 2, go ahead.
Okay, Eileen, our long wait may be over. And so on behalf of the many millions of people who believe so deeply in what we do, good luck, Godspeed, and have a little fun up there.
Well, thanks to you, to the launch team, and to everybody in the shuttle program. The crew is go for launch.
Copy that, thank you. NTD, you are clear to proceed with this launch. Copy, thank you.
Standing by for retraction of the crew orbiter access arm.
TLS is go for orbiter access arm retract.
Discovery, OTC. It's time for you to return to flight. Our hopes and prayers ride with you. Godspeed, and we'll see you in a couple weeks.
And OTC Discovery, thank you very much.
That was orbiter test conductor Mark Taffet here in firing room 3. The rotating service structure can be moved back into position very quickly if there's an emergency in about 28 seconds. Main engine gimbal check, steering check coming up. And now we should have retraction of the gaseous oxygen vent arm, the Gox vent arm. We'll pull away from the top of the external tank, the beanie cap so-called.
Discovery, OTC, close and lock your visors and initiate O2 flow.
T-minus 2 minutes.
Visors on, O2 flows and work.
TLS is go for ET, LH2 pressurization. MS5.
External tank bipod heaters now being deactivated.
1 minute, 30 seconds.
Firing chain is armed.
20.
Sound suppressor water system is being activated. Range systems armed. T-minus 10 seconds. Go for main engine start. 7, 6, 5. 3 engines up and burning. 3, 2, 1. And liftoff of Space Shuttle Discovery, beginning America's new journey to the moon, Mars, and beyond. And the vehicle has cleared the tower.
Houston Discovery, roll program.
Roger, roll, Discovery. Roger, Discovery.
Houston's now controlling. Commander
Eileen Collins confirming Discovery is rolling onto a course for rendezvous with the International Space Station. 30 seconds since launch, Discovery is already traveling 400 miles per hour. Altitude 12,000 feet. This is a view from a camera mounted on Discovery's external fuel tank. 3 engines on Discovery are now throttling down to 2/3 throttle to prepare the spacecraft to pass through the area of maximum air pressure and go supersonic. One minute since launch, Discovery speed now 900 miles per hour.
Discovery Houston, go at throttle up.
Discovery, just go with throttle.
All systems remain go for Discovery. Altitude now 9 miles, 6 miles northeast of the launch pad. One and a half minutes since launch, Discovery's already consumed more than 2.25 million pounds of propellant. It weighs less than half of what it did at liftoff. Speed now 2,000 miles per hour. Altitude 18 miles, 14 miles northeast of the Kennedy Space Center. Standing by now for burnout and jettison of the twin solid rockets. Booster officer confirms clean separation of the solid rocket boosters. Discovery now on its 3 main engines, second stage. Speed now 3,030 miles per hour. Altitude 33 miles, 40 miles downrange from the Kennedy Space Center. Discovery's orbital maneuvering system engines are now firing to assist its climb to orbit. They'll fire for about 2 minutes and 19 seconds. This again a view from a camera on the external fuel tank for Discovery.
Discovery Houston, 2-engine Zaragoza.
Discovery is 2-engine Zaragoza.
That call that Discovery could perform a transatlantic landing at a Spanish Air Force base in Zaragoza, Spain if required. 3 engines continue to operate well. All systems in good condition. Altitude now 254,000 feet or about 48 miles. Discovery speed 4,500 miles per hour. 85 miles northeast of the Kennedy Space Center. About 5 minutes left until cutoff of Discovery's 3 main engines. Discovery's altitude now 59 miles. Speed 5,500 miles per hour.
Discovery Houston, negative return.
Discovery is negative return.
That call confirming Discovery's gained too much speed and altitude to return to a landing at the Kennedy Space Center if that were required. All systems remain go for Discovery. Just over 4 minutes to cut off of the main engines. During that time, Discovery will more than triple its current speed to reach the 17,400 miles per hour required to achieve Earth orbit. Discovery 200 miles northeast of the Kennedy Space Center now. Altitude 65 miles, speed 6,700 miles per hour.
Discovery Houston, press to ATO.
Discovery Discovery is pressed to ATO.
That call indicating Discovery could reach a lower than planned but safe orbit on only 2 engines if needed. All 3 engines continue to operate well at full throttle. Speed now 8,000 miles per hour. Altitude 67 miles, 300 miles northeast of the Kennedy Space Center.
Discovery Houston, single engine ops 3.
Discovery is single engine ops 3.
Discovery can perform a transatlantic landing on only 1 engine if required. All continuing to go well. Altitude 67 miles, 350 miles northeast of the Kennedy Space Center. Discovery speed now 9,200 miles per hour. Discovery is rolling to a heads-up position now to assist its performance as it finishes its ascent to orbit.
Discovery Houston, press to MECO and single engine Zaragoza 104.
Press to MECO and single engine Zaragoza 104.
Those calls that Discovery could reach its planned orbit on only 2 engines if needed. All 3 continue to operate well at full throttle. Just under 2 minutes to cut off of the main engines now.
Discovery Houston, we see a nominal shutdown plan. You will be go for the plus X and go for the pitch maneuver.
Nominal shutdown plan, go for the plus X and go for the pitch maneuver.
Good copy.
About 1.5 minutes to cut off of the main engines. Those calls confirming that the crew is go to do a plus X maneuver after jettison of the external tank to clear.
Discovery Houston, single engine press 104.
Single engine press 104.
Plus X maneuver to clear the tank, and also then a pitch maneuver that will provide handheld photography by the crew through the windows of the vehicle of the external tank after it's jettisoned. 1 minute to cut off of the main engines now. Discovery speed 13,300 miles per hour. Altitude 65 miles, 615 miles from the Kennedy Space Center. Discovery's 3 engines are now beginning to throttle back to prevent the spacecraft from experiencing forces in excess of 3 times that of Earth's gravity as it continues to accelerate. Speed now 14,800 miles per hour, altitude 63 miles, 700 miles northeast of the Kennedy Space Center. 30 seconds to cut off of the main engines. Discovery speed now 16,000 miles per hour. Standing by for cutoff Discovery's 3 main engines. Booster officer confirms main engine cutoff for Discovery. Standing by now for jettison of the external fuel tank. Live television as Discovery jettisons its external fuel tank. All normal with the cutoff of Discovery's main engines. Discovery performing a maneuver to fire its jets and ensure clean separation from the tank.
Discovery, we have a good plus X maneuver.
Copy the good plus X. We saw a nominal MECO. OHMS 1 is not required.
Nominal MECO, OHMS 1 not required.
And this is the
let's go for maintenance start.
After many, many years of work, we got Discovery. A lot of tears in people's eyes when we finally lifted off. We cleared the tower going better than accelerating through 100 miles an hour.
Houston Discovery, roll program.
Roger, roll, Discovery.
A view of the crew in the upper left in the flight deck. We had a camera on our external tank. This is the LOX feed line. You see the ET over to the right, the booster on the left. The purpose of this camera was to watch the any debris that might fall off. We've got the booster separation here. The cameras on the boosters actually follow them down to the ocean. And as you know, they're retrieved and reused. Back to the LOX feed line camera. first time we've flown a camera in this position. It worked quite well. Here's the roll to heads up. You can see the horizon in the background. That was about 6 minutes in the flight. Here we are about 8 minutes and 20 seconds. We have main engine cutoff. And shortly after that, you see the forward attach point. We're going to separate from the tank. The tank is going to fall away, and we will pitch around.
Houston Discovery, we have a good +X maneuver.
We'll pitch around and photograph the tank.
As you look at this sequential still video through the orbiter's S-band communication system, right around the middle of your picture, there's the grapple fixture for the external stowage platform. That's a large tool storage platform that will be attached to the Quest airlock of the International Space Station on the third and final spacewalk of the mission, to be conducted by Soichi Noguchi and Steve Robinson. Behind that, the barrel-shaped object is the Raffaello multi-purpose logistics module, the cargo module near the rear of the payload bay that is equipped with about 15 tons of food and water and supplies, as well as experiment hardware for the crew on board the International Space Station, Commander Sergei Krikalev and NASA flight engineer and science officer John Phillips, who are tidying up the station today in preparation for the arrival of their first visitors, since they themselves arrived on the International Space Station back in mid-April. Once the shuttle's robotic arm grapples and unberths the orbiter boom sensor system and brings it to what is known as a high hover position over the payload bay, then the shuttle's Ku-band communications antenna will be unfurled. Typically, that antenna, which provides high data rate telemetry and television from the shuttle, is deployed on the first day of the mission right after launch. But because of some concerns over possible clearance and interference issues, very tight clearances between the end of the boom itself and the Ku-band antenna, flight controllers and mission managers crafted a flight plan to play it safe very conservatively, to get the boom out of the way first before the Ku-band antenna would be deployed. Once it is deployed and we have a high data rate telemetry capability, the imagery that was taken from the external tank umbilical well cameras in the belly of the orbiter yesterday following launch, following the external tank jettisoning and separation by the orbiter from the tank, that imagery will then be downlinked as another set of images for the imagery assessment team to analyze in its ongoing deliberations for the mission management team. The robotics officer here in the shuttle flight control room reports that mission specialist Andy Thomas is now poised directly above the electrical flight grapple fixture at the end of the orbiter boom sensor system on the starboard sill of Discovery's payload bay, and we're standing by for the actual motion of the end effector to reach out and grab that grapple fixture in the first step on the road to unberthing the boom and creating a 100-foot-long crane.
Houston Discovery for PDRS, no need to respond. We're going in for the grapple.
It has now been grappled, 2:25 a.m. Central Time. The robotics officer here in the shuttle flight control room reporting a good grapple. So we now have a hard fix between the end effector on the shuttle's robotic arm with the 50-foot-long boom extension. And there's our first television views of this mission through the Ku-band communications antenna. This view from the camera at the rear of Discovery's cargo bay, looking to the forward portion of the cargo bay, you're looking at the Raffaello multi-purpose logistics module on the lower left-hand portion of your screen. The shuttle's robotic arm grappled onto the orbiter boom sensor system, hovering over the starboard sill of the payload bay. The survey of the starboard wing leading edge panels of Discovery has now gotten underway. The crew deciding for conservation of time to begin with panel number 1, which is the inboard panel along the fuselage, and then move outboard toward the end of the wing.
Discovery Houston for...
Houston Discovery for LDRI.
Go ahead, Vegas.
Yeah, just to let you know, as expected, the LDRI lasing the wing gave a great illuminator for the RSC camera.
That's great to hear. Thanks for those words. Discovery Houston, we show you in attitude. You can pick up with the shoulder yaw in step 3 of the single joint. Once you're in position, you can go back and pick up step 2 to do the RCS actions if you'd like.
This is Mission Control Houston, an impressive view of the aft portion of the shuttle Discovery, looking out over the starboard wing, now directly over the vertical tail fin and the orbiter maneuvering system pods. About at the middle of your picture, that dark circular object is control moment gyroscope. That will replace the failed control moment gyroscope in the Z-1 truss of the International Space Station during the second of the 3 spacewalks by Soichi Noguchi and Steve Robinson. This is Mission Control Houston, 21 hours, 43 minutes into the flight of Discovery. The shuttle passing off the southwestern coast of Australia, about to begin a swing over the southern Pacific Ocean in pursuit of the International Space Station on this day of inspection of the orbiter's wings and its nose through the use, for the first time ever, of an orbiter boom sensor system, a 50-foot-long boom extension affixed to the grapple fixture to the shuttle's robotic arm to form a 100-foot-long crane that is being used to analyze the reinforced carbon-carbon on the leading edges of the 22 panels comprising the 2 wings, 22 panels for each of the wings of the orbiter, and the reinforced carbon-carbon on the nose. At 4:45 this morning, Andy Thomas, along with Charlie Camarda and Jim Kelly, began the inspection of the starboard wing leading edge panels, all 22 panels. And then, with that having been completed, an hour and 45 minutes later, recalibrated the sensors and now began the inspection of the nose cap that got underway about 15 minutes ago at 7:06 a.m. Central Time. Directly in front of the orbiter, taking a self-portrait of the nose of the shuttle Discovery as it moves in a zigzag position to cover all of the pertinent areas of interest, ensuring that the nose incurred no damage during Discovery's 8.5-minute climb to orbit yesterday.
Mission specialist Charlie Camarda and Andy Thomas indicating that that's them. You can see waving to the cameras on the Space Shuttle Discovery's robotic arm as they control the robotic arm through a survey of the crew cabin. Again, this is another leg of the inspections that are taking a look at the condition of the heat protection systems on board the Shuttle Discovery following yesterday's 9:39 a.m. Central Time launch and climb into orbit.
Okay, here we go then.
With that, Orbit 2 Flight Director Tony Sacacci and Spacecraft Communicator Julie Payette giving Andy Thomas and company the go-ahead to begin the survey of the crew cabin, even though they don't have a tape in the deck on board.
For the DTD.
Go ahead.
Yeah, just to catch up, the error message we have, it's the C column 32, I believe it's message 32. And looking at the page 12-17 on the photo TV checklist, and we managed to get the jump tape out, but the error message still exists after the power cycle.
So Ichi, we copy that. Let us look at it.
Again, this is video that was taken by Soichi Noguchi from the flight deck of Discovery moments after orbital insertion, shortly after Discovery was launched on Tuesday from the Kennedy Space Center.
Discovery Station, how do it?
Hello, Sergey. This is Space Shuttle Discovery on the Big Loop. We hear you loud and clear. How us?
Not very loud, but very clear. Glad to hear you. We're waiting for you.
Okay, glad to hear you too.
Discovery now being manually flown from the aft flight deck by Commander Eileen Collins. Range is 950 feet, closing at a rate of 1.5 feet per second.
Houston, Alpha, Discovery, RPM start in 2, 1, now.
Sergey, RPM start now.
The rendezvous pitch maneuver is underway, having begun at 5:15 a.m. Central Time.
And Sergey, the orbiter's through about 4 or 5 degrees of pitch now.
Standing by for the command to initiate photography.
Houston, Discovery, Underground 2 and free drift.
We see it. Sergey, about 55 degrees more pitch to go before we give you the start photo call.
Okay. Synchronized spaceflight at an altitude of 222 statute miles over Europe as Discovery continues the rendezvous pitch maneuver. The station crew standing by for the initiation of rendezvous pitch maneuver photography.
Alpha, Discovery, about 20 seconds to photo start.
Sergey, about 10 more seconds, we'll have you start clicking your photos.
Okay. Alpha, Discovery, start photos.
Start photos, Sergey. Start photos, Sergey.
Photography has begun aboard the International Space Station. Looking out of windows in the Zvezda service module, Sergei Krikalev manning a digital camera with 800mm lens, John Phillips with a 400mm lens, as the rendezvous pitch maneuver continues.
Coming through a pitch of about 180, another 15 degrees to go. Another 15 to go.
Alpha, Discovery, in photos.
And with that direction by pilot Jim Kelly, about a minute and 40 seconds worth of photography accomplished by Krikalev and Phillips.
Continue to click and we'll get the aft end here in a minute.
Okay. Okay.
Of course, the station crew free to continue photography as it desires, but the prime areas of interest resulted in about 1 minute and 40 seconds worth of usable photography.
And Houston, are you receiving the view of the station rising?
Discovery, we are. It's a beauty.
Commander Eileen Collins at the aft flight deck of Discovery, flying the final few feet just prior to docking. The Space Shuttle Flight Control Room reports a perfect approach by Commander Eileen Collins.
2.5 minutes to contact.
Houston, Alpha, Discovery, we have contact and capture. Shuttle is in free drift.
Here, Commander Eileen Collins prepares to open the hatch into the International Space Station following today's 6:18 a.m. Central Time docking. Shaking hands with International Space Station Expedition 11 Commander Sergei Krikalev and entering the station.
Discovery's crew now aboard the Destiny Laboratory. Eileen Collins was first in, followed by Soichi Noguchi. Steve Robinson now aboard. Charlie Camarda now joining his crewmates.
arriving.
John Phillips, former naval officer, with the now famous tradition of ringing on board the visiting crew of Discovery. Andy Thomas now on board the International Space Station for the second time.
Captain, United States Navy, arriving.
That for Wendy Lawrence.
Andy, we're now getting the WDS images. If you can hold that for a couple seconds, we'd appreciate it. We'll let you know when we're seeing enough. Copy that. And it looks good. We're getting a real good image now. Okay, there's our first Bob and Noah. I'm sorry I didn't. We throw it on the video, don't worry. Okay, Suchi. Okay. Gonna force it in. Space spackling. I will work this a little bit. It's about like pizza dough. Like licorice flavored pizza dough.
One of the things they want to see in these tile repair tests is how well this material can be soaked into the tile substrate, in addition to its being able to help improve the heat rejection capability of the tiles. It's also intended to be a primer for larger tile repairs when the STA-54 ablative material is squirted into large damage areas like the one he's working on now.
That works pretty well.
This is Mission Control Houston. Spacewalker Steve Robinson has removed all of the launch bolts from the external storage platform attachment device. He's holding it in his hands as he is suspended from the space station's robotic arm. Jim Kelly inside the space station's Destiny laboratory module will now begin to maneuver Robinson and the S-Pad, as it's known, up to the Quest airlock module for installation there.
Hey, thanks for the heads up, Biggest. Well, my head's down. 19. Good motion, Vegas.
Copy, Stephen. We'll be looking for any stop calls from you, and we'll expect to hear all stop 3 times if you see anything you don't like.
Copy that. There just are no words to describe how cool this is.
There's a view of Steve Robinson at the end of the Canadarm2, ready to begin his transport down to the belly of the Shuttle Discovery for the removal of these tile gap fillers.
I remind you to use less than 5 to 10 pounds of force. Let us know if more force is required, and if you do succeed in pulling it out, GCA the arm away prior to putting it in your trash bag. Okay, yours. Are brakes set?
The brakes are on. You're a go.
Okay, I'm grasping it, and I'm pulling. It's coming out very easily. Beautiful. Very nice. Okay, Steve, GCA the arm back away. Okay, away from my body. I'd like to move body back by 5 feet, please.
Okay, brakes are coming off, and we will move aft away from structure.
As you look from the helmet camera on Robinson, you can see the gap filler in his fingertips.
Get some clearance.
Brakes are on. Your go from M2.
Thank you. Here we go. Everybody watching. Nicely done, Steve. Back to you to GCA away from there. Okay, that came out very easily, probably even less force. It looks like this big patient is cured. Copy that.
At the juncture between insulation blankets and tiles on the port side of the Space Shuttle's crew cabin. This is an area directly below the commander's window. Mission managers are continuing to look at a variety of different images that have been downlinked, and they'll add these images to the suite of information they have to review as they consider options related to this and whether it's going to affect Discovery's re-entry into the atmosphere. Looking at the port wing of Discovery.
Hey, Houston, Vegas and Charlie are sending you a nice view of the bottom of the orbiter.
on TV. Eileen, we have it. It is awesome. Discovery Houston, this is an extraordinary picture, and it's been broadcasted on NASA TV, so for the whole world to see. Awesome. And just a thought for you guys, at the end of the OBSS now, that's far away from the shuttle, and that's where we're going to put an EVA crew member next time around.
And yes, it is time to come home. We got an extra day on orbit as we waited for the weather to get better in Florida. Here's Wendy suiting up in the middeck. But we didn't get to come home on the first try as the weather was bad in Florida. So on the second try, we did our entry into Edwards Air Force Base in Florida. And you get a look at the displays that we use on the flight deck. Our entry was at night, and in fact, we landed about 1 hour before sunrise at Edwards. This is the view looking back out the overhead windows. That's the plasma trail that forms above the shuttle. And you get another view from here. I don't get a chance to turn around and look at this, but our flight deckers in the back get a chance to do that, and I'm glad they filmed that for us. This is from the ground at Edwards. It's an infrared view, which is the heat that you can see that has built up on the outside of Discovery. You can see our nose, the RCC on the nose gets the hottest. This is the pre-flare. We're getting ready to do the landing. The gear is down. And we touched down on runway 22 at Edwards. After some post-landing checklists, we walked off the Astrovan and got a chance to walk around and look at the exterior of Discovery, and we found that it was in absolutely great shape. We got a chance to say hello to our families here, who unfortunately were in Florida, but we did get to come back and see them the next day. And that's really a great